Okay, in this video we're going to look at some trigonometry review, some things you know from last year, and a couple new formulas that you're going to need for this year. Okay, so what you're seeing here on the left, secant of x is equal to 1 over cosine x. So last year we worked primarily with sine, cosine, and tangent. And so now this year we're adding the reciprocal trig functions to it. And so you need to know that secant of x is equal to 1 over cosine x. You need to know that cosecant of x is equal to 1 over sine x, and that cotangent of x is equal to 1 over tangent x, which is also equal to cosine x over sine x. Okay, and so the thing that people get confused here is they see secant, and they automatically want it to go with the sine of x, and it doesn't, it's the opposite. So secant goes with cosine. So remember that you got to have one s and one c, and then cosecant goes with sine, and cotangent goes with tangent, and that one makes sense to us, okay? And since tangent is sine over cosine, if that was on the bottom of a fraction, we would multiply by the reciprocal, and that's how we get cosine over sine. Okay, now these on the left you have to memorize. You are not going to be given those. But the ones you see on the right, you're going to be given those. Those are on your reference sheet. Now, this is the one that we worked with last year a lot. Sine squared plus cosine squared equals 1. And you remember that that can be manipulated so that we can say cosine squared of theta is equal to 1 minus sine squared of theta. Or we can say that sine squared theta is equal to 1 minus cosine squared theta. So that can be used in any of those three ways. The two that we're adding this year, and again, they're on your reference sheet, are 1 plus tangent squared theta is equal to secant squared theta, and 1 plus cotangent squared theta is equal to cosecant squared theta. And so again, these can be manipulated and used in other ways, just like the one above. So I could say tangent squared theta is equal to secant squared theta minus 1, and that one pops up a lot. Or I could say 1 is equal to secant squared theta minus tangent squared theta. So you're just using algebra to manipulate these. Down here, I could say cotangent squared theta is equal to cosecant squared theta minus 1. Or I could say 1 is equal to cosecant squared theta minus cotangent squared theta. Okay, and one other thing I want to point out, secant is sec of x. Cosecant is cosec, and sometimes you will see this one as cscx. Okay, so just if I happen to write that or you see that, don't get confused. That's just another way to write cosecant. Okay, so let's look at using these. So we're asked here to find the exact value, meaning we can't give decimals, of secant of 1/3 pi. Now, if you know the unit circle, you can use the unit circle to figure this out, but on the Cambridge exam, you are allowed a calculator, but you notice that your calculator doesn't have a secant button. So what we would do is we would rewrite this as 1 over cosine of 1/3 pi. And then you would just do that math in your calculator, or you would use your knowledge of the unit circle to figure out this, and then you have your fraction. In this case, it simplifies to 2. Over here, cosecant of 3/4 pi, we would write as 1 over sine of 3/4 pi. Remember that cosecant goes with sine. And then you can do the math now in your calculator, or again, using knowledge of the unit circle. Cotangent of 7/6 pi, we would write as 1 over tangent of 7/6 pi, and then you can type it in your calculator, and that's going to give us the square root of 3. When you're typing these in your calculator, just be careful to use parentheses as appropriate, or I'd probably use the fraction bar in your calculator and type it in exactly like you see it. I threw this one in there just because we need to pay attention to our mode on a test. If we're given radians, we need to be in radian mode. But if we're doing anything with degrees, then we would need to be in degree mode. This, though, is cotangent of 300 degrees, and that would be 1 over tangent of 300 degrees, and that would give us negative square root of 3 over 3. And again, we have to give our answer like that because it asked for an exact value, so we're not allowed to give decimals. Okay, so this is a good review of your rules when solving trig. Guys, this isn't going to go away. You're going to use it a lot this year, especially in this chapter, but in other chapters, so you have to know this. So this is going to be a good review. Find the values of the following for this interval So 0 to 2 pi, which tells us we need to be in radian mode, and they want us to give our answers correct to 3 significant figures. So we have cotangent of theta equals 0.4. Again, we don't want to deal with cotangent, so we're going to rewrite this as 1 over tangent of theta equals 0.4. And I want to get tangent theta out of the denominator. So algebraically, you guys know you can do this. You can multiply by tangent of theta to both sides. And then we have 1 equals 0.4 tangent of theta. And to solve, I want tangent by itself, so I'm going to divide by the 0.4. Notice this side is the reciprocal of the 0.4. And so you can, and you'll get good at this, and you can go straight to the fact that tangent of theta is going to be equal to 1 over 0.4, which is 2.5. Okay? So just, you could go straight here if you understand that concept, and you'll see me do that in class, okay? Now, how do we solve for an angle? We say tan inverse of 2.5 equals theta. And so theta is equal to, and we can do this in our calculator, and when we do that, we get 1.19. And this is me rounding to 3 significant figures. When you do the math with this, you're going to want to keep the full answer in your calculator until you get to the end. But I'm going to not write it all out. So I'm going to write 1.19. Okay, now we're not finished because I have this answer, but tangent rules say that I can take this answer and I can add or subtract 180 or pi. Pi in this case for us since we're in radians. So I'm going to take this 1.19 and I'm going to add pi to it. And when I do that, I get 4.33. So now 1.19 is definitely in this interval. If you were unsure, 2 pi is like 6.28. So 1.19 is there. So is 4.33. And I would actually try adding pi again, because I need as many answers as I can get in this interval. In this case, it doesn't work, and we go over the interval. We get 7.47. Okay, so you have to memorize those rules again. I know you've had a summer off, but those are important. So over here, let's look at this one. We have secant of theta. Remember, secant is going to be 1 over cosine of theta equals 4. Now, again, you can do the algebra, multiply by cosine theta on each side, and then divide by 4. But because I know how this works and I understand that secant is 1 over cosine, so cosine is 1 over secant, I'm going to say I know that cosine of theta is 1/4. And then theta is going to be equal to cosine inverse of 1/4. And when I do that math, that is going to give me 1.32. Again, this one's in my domain. It's in my 0 to 2 pi. But I need to know my cosine rules. My cosine rules are different than tangent rules. Cosine says I can take this angle, I can take its opposite. So in this case, I can make it negative. And even though that is not between 0 and 2 pi, I can take both of these and I can add or subtract 360. 360 or 2 pi. Again, 2 pi in our case because we are in radians. So if I add 2 pi to this, I am going to get 4.97. And that one is in this 0 to 2 pi range there. This is in 0 to 2 pi. That's my interval. 4.97 is there. But if I added 2 pi to this one, obviously this is a positive number plus 2 pi. It's going to put me outside of 2 pi. And so my only answers for this one are 1.32 and 4.97. Okay? Okay, so on this example, I'm asked to find the values of theta in the interval 0 to 360. So 0 to 360 degrees. That tells you you need to put your calculator in degree mode, so be careful and watch out for that. And we're asked to find values of theta between 0 and 360 for secant squared theta equals 4 plus 2 tangent theta. So I have a secant squared theta and a tangent theta, and I want to see if I can get those to be similar, if possible. And so if you go back and you look at the 3 equations or identities that I gave you at the beginning, we can see that 1 plus tangent squared theta, this was one of them, is equal to secant squared theta. And so this is tangent theta, it's not squared, so I can't do anything with that, but I can take this secant squared and I have secant squared theta over here, and so I can plug this 1 plus tangent squared in. So I can write 1 plus tangent squared theta to replace that. And then I have a tangent squared and a tangent. And hopefully you remember from last year that when we have the same, like both tangents, but one's squared and one's not, then it's probably quadratic and I can probably solve it that way. So I'm going to rewrite this with the tangent squared theta first. I'm actually going to move this 2 tangent theta to the other side by subtracting, and then when I move the 4 over, I'm going to get a negative 3. Okay, and so this is what I have. Now I notice that this is squared, this is not squared, and this one doesn't have a tangent. So it does look like a quadratic. Looking at my coefficients, this one's 1, this one's negative 2, and this one's negative 3. And so what I'm going to have is tangent of theta minus 3 and tangent of theta plus 1. Okay, and if I try multiplying that back out, I do get what I had up here. So that works. And then we set both of them equal to 0 and solve, which gives me tangent of theta equals 3. Over here, I'm going to have tangent of theta equals negative 1. And then we solve both of those using our tangent rules just like normal. So this is going to be theta equals tan inverse of 3. And that is going to give me 71.6. Again, there's a longer value there, so I would be using that when I do this math. I'm going to look at my interval here. I have 360 degrees. I'm good there. But I want to see if I can get any more. And remember the tangent rules is I can take this and I can add 180 or pi to it. So I'm going to add 180 to it. And when I add 180, I get 251.6. And so this is one of my answers because it's in this interval from 0 to 360. And this is one of my answers. And I could try adding 180 again, but if I add 180 again, I'm going to be outside of 360. So now let's solve this one. Theta equals tan inverse of negative 1. And so theta is going to be equal to negative 45. That is not between 0 and 360, but we're going to use it anyway, and we're going to apply the tangent rules, which means I can take this and I can add 180 to it. And when I add 180 to it, I get 135, and that one is between 0 and 360. Well, I can take that 135 and I can try to add 180 again. And in this case, I get 315, which is also between 0 and 360. So my answers for this problem are 71.6 degrees, 251.6 degrees, 135 degrees, and 315 degrees. So you need all 4 of those to get full points. Okay, so I want you to take a minute and try to solve this problem. Pause the video, try it on your own, and then come back and check your answer with mine. Okay, so this one is very similar to the last one, except this time we have a tangent squared and a secant that is not squared. And so if you went back and looked at your formulas, you would have 1 plus tangent squared equals secant squared. So I'm actually using the same formula we did last time, but in this case I want tangent squared by itself so that I can replace this tangent squared. So I'm going to move my 1 to the other side, and that's going to give me tangent squared theta equals secant squared theta minus 1. And then I'm going to put all of this in place of that tangent squared. And so that's going to give me secant squared theta minus 1 equals 1 plus secant theta. And again, this is secant squared and this is secant to the first power. And so it's looking like it's probably going to be quadratic. So let's move everything to one side, just like we would a regular quadratic. And then when I move this one, I'm going to have minus 2 equals 0. And let's factor. If you can't factor, you can always use quadratic formula, but most of these are factorable. So I'm going to have secant of theta minus 2 and secant of theta plus 1. And again, always check, double check, if you multiply that out, you get what you started with right here. And so secant of theta is equal to 2. And secant of theta is equal to negative 1. Now, when we solve this one, we have to use our new rules, our reciprocal trig values. And so secant is equal to 1 over cosine theta equals 2. Now again, you can actually do this math where you multiply both sides by cosine and then get cosine theta by itself, which you all know how to do. Or I could go straight from this and I could go, well, I know that since secant is equal to 1 over cosine is equal to 1 over this value, since secant is 2. And so I have this, and so I can solve that. And I get theta equals cosine inverse of 1/2. And now we need to check, this is 0 to 360, so we're still in degree mode. So I'm going to get theta is equal to 60. And then I have to follow cosine rules now. So cosine rules say I can take this value, I can take the opposite of it, which is negative 60, and I can actually add or subtract 360 to both. You have to know those rules, okay? And so in this case, I know that 60 is between 0 and 360. But if I add 360 to that, it's not going to put me where I need to be between 0 and 360. And subtracting 360 would give me a negative value, which isn't going to work either. So if I take negative 60 and I add 360, I get 300. And that does work. So those are the two answers I get from this one. And then over here, we're going to do the same thing. Secant of theta is equal to cosine of theta. And it would really be cosine of theta equals 1 over this value, but 1 over negative 1 is negative 1. So negative 1 is the reciprocal of negative 1. And so theta is equal to cosine inverse of negative 1. And that is going to give me 180. Again, cosine rules. I take this value, I take its opposite, and I can take both of those, and I can add or subtract 360. This one is between my 0 to 360, so I'm good there. If I add 360, I'm over my values, and if I subtract 360, I get a negative, and since we started at 0, that doesn't work. If I take my negative 180 and I add 360, I get positive 180, which I already had, and so that's the only answers I'm going to get. So this time I'm going to have 3. I'm going to have 60 degrees, 180 degrees, and 300 degrees. Okay? Okay, just a couple more I want to look at. This one just says simplify. There's no equal sign in it, so we just want to simplify it down to something that hopefully looks nicer. Okay, so if you looked back at what I gave you, we know that cosecant squared theta is equal to 1 plus cotangent squared theta. And so I'm just going to take this whole side, and I'm going to replace cosecant squared theta. So I have the square root of 1 plus cotangent squared theta minus 1. And then you see that this 1 minus 1, those are going to cancel out. And I'm going to be left with the square root of cotangent squared theta. And since cotangent is squared, and the square root of something squared is just itself, I get cotangent of theta. And that is just pretty simple. So I probably want to stop there. I can write cotangent in many ways. I can write it as 1 over tangent. I could write it as cosine over sine. But again, those introduce fractions, so I probably just want to leave it as cotangent of theta. Okay, last problem, and this one's just a little bit more complicated. So we could do several things. I can take tangent, and I can make it sine theta over cosine theta. And then I'm going to have on the bottom, instead of cosecant squared, I'm going to write this as 1 over sine squared theta minus 1. Because I'm trying to get these so that we have the same thing as much as possible. So multiple sines or multiple cosines. And so I've got it down to just sine and cosine at this point. But I need to be able to put these together. So now I'm going to leave my numerator alone for a second. And I am going to find common denominators. And so if I want this 1 right here to have a sine squared on the bottom, what I'm doing is I'm multiplying by sine squared theta over sine squared theta to that 1. And that's just going to give me sine squared theta over sine squared theta since it is 1. Okay, so now I can write this as a single fraction. I'm going to write sine theta over cosine theta. And when I say a single fraction, I mean a single fraction on the bottom. I'm going to have 1 minus sine squared theta over sine squared theta. Now I have a fraction divided by a fraction, and we know that when we have that, we can multiply by the reciprocal of the bottom. So I'm going to leave the numerator alone times the reciprocal of this fraction in my denominator. So I'm going to have sine squared theta over 1 minus sine squared theta. Now you can see on the top I have sine and sine squared, and it's multiplication. So I'm going to have sine cubed theta. And then here on the bottom, I don't actually want to distribute that out because I can see that if I leave it like this, hopefully you remember from last year that 1 minus sine squared theta is actually equal to cosine squared theta because we have the formula or the equation sine squared plus cosine squared equals 1. And it's actually identity, but we use it a lot to substitute values. And so I can write this as 1 minus sine squared theta equals cosine squared theta. So I'm going to replace that. I'm going to have sine cubed theta over cosine theta times, and instead of 1 minus sine squared, I'm going to have cosine squared theta. And then you see that on the bottom, I now have 3 cosines. So I'm going to write cosine cubed theta. And this is sine cubed theta over cosine cubed theta, which just makes tangent cubed theta. And again, that's pretty simple. So we simplified it all the way down to just tangent cubed theta. Go back and review what you need to. I'll see you in class.